Hello everybody, welcome back to the channel. D2 here. Thought I'd do a video to start off a new series on deep sky astrophotography, site planning, target planning, long-term planning for various rigs you might want to have for different types of targets, etc. But starting at the very most basic area will be site planning. So thought I would start with, the way I started out, which was local planning at my house. When I first got a telescope, didn't really know what I was doing. I just started going outside, looking up at the sky and seeing the stars, and no clouds were out, and I would go out and do that. Eventually I learned about seeing, then I learned about transparency, and I learned about light pollution, etc., etc. This video is going to start looking at how I used to plan and then how I plan now in terms of the weather. Regardless of where you shoot, regardless of what rig you shoot, regardless if you're just doing visual versus deep sky, astrophotography versus planets, this will work for any of those situations. A couple of things we want to hit on first before we get into that is a couple terms. So first one is transparency, and I have the most simple definition here. Transparency is just how clear it is outside versus seeing, which is how turbulent it is. So one is like if you were looking in a pool of water, how clear is the water versus how turbulent the water, someone's splashing the water versus how cloudy the water is. That's the best way to think about these terms. And summing it up, one is about clarity, one is about steadiness. So these measures are something I use within the software tool. Astrophotography is the main tool I use now. I used to use a different tool, Clear Outside. I still look at Clear Outside every once in a while just for a really high level view of what's going on for the week. So with that, let's switch over to the views here of the software that I'm talking about. So the first one I used to use, Clear Outside, still an okay tool. Some people argue it's nowhere near as accurate as Astrophotography. I want to say atmospheric, but it's Astrophotography. And your mileage could vary on either one of these. They both get updated regularly. I'm not sure of the time frame for forecast updates on Clear Outside, but on Astrophotography, it is, I believe, every 6 hours on the different cloud models. There's a free version of Astrophotography and a professional version. I have the professional version. So I used to go out, I look outside, or I'd look at the local weather, is it going to rain or not? And I would have this on a mobile app, and I would look out. So for example, I'm just pointing at Oklahoma City as a target. That's not where I live or anything. But an example would be if I looked and I saw that it was green all night, and then I could see the moon coverage, which I didn't even understand the moon at times. So forget about the moon for a minute. Just, when you first start shooting, just think about when is it going to be dark, and is it going to be no cloud coverage? I look down here, none of these nights are any good. These red, yellow, I don't even need to look at the other app. If I were comparing the two, they are both very accurate when weather's bad. It really comes down to when there's yellow areas, like this one. So if I were to open up, say I was going to go, oh, this is a good week, and I opened it up, I could get some additional information. I could look at the cloud cover at different levels up here. I could look at the wind is high enough that could affect some telescopes, many telescopes. So this will go yellow as well when the wind is high. And you can also see the temperature, and this is in Celsius. Mental math if you're doing Fahrenheit. Depending on if you're using batteries, temperature can be bad. So I shoot up to minus 10 Celsius, 14 degrees Fahrenheit, 15 for rounding off. And I do that because the temperature rating of my batteries is minus 10 Celsius. And I quite frankly don't want to be out there any colder, so I use it as an excuse to not shoot if it's colder than that. This is a good way to get started. You look at these nights and you can pick one. You can look ahead and wait for a good night to come along. I usually check every couple days. If this were all bad, and I would just check, okay, I don't need to look for couple days, look out, okay, say this green bar was down here and coming up, I would eventually just check it, and I check it the day before. When you check one day before, you're usually fairly well locked in on what that's going to look like. And then I would go and figure out what I was going to shoot, make sure I had my timeline for setting up my gear, etc., which I'm not going to cover on this video. But that's the way to get started when you first don't know anything. Then eventually, once you understand the difference between the moon being out and how that affects what filters you're using, depending on if you're using one-shot color, different filters there for light pollution versus mono. I only shoot mono. Then this will tell you, depending on where the moon is, and that would be something I'll show later on in another video with the rig setup, how to plan around where the moon is in the sky, depending on if you're trying to push in a target that's not conducive to the moon being out. Things like LRGB, luminance, red, green, and blue are going to be affected by the moon depending on where it is and what stage it is. And you can see the stage over here. So this is a pretty bright, almost half moon here, and it's going to be coming up, and it's going to be up 2/3 of the night here. Early on, it's not even above horizon, so you can go ahead and be shooting anything. And even probably a couple hours into here, it's not going to impact too much, depending on where you're shooting versus where the moon's coming out. Later on, as you learn more and start using narrowband, hydrogen, sulfur, oxygen filters, those narrowband filters are less prone to moonlight. And in some cases, it has no impact at all. If you were pointing straight at the moon, that would be maybe a different issue. But with those filters in place, you could theoretically just shoot a narrowband target, nebula versus galaxies, and some nebula would be in LRGB, but generally nebula are going to be HSO, narrowband targets. So this night might be good to just shoot nebula, narrowband all night. Down here, if this were a green night here, the moon's not out at all. So this could be, if it were green, this could be a night for a galaxy target using non-narrowband. If you wanted to shoot it, you can obviously shoot narrowband anytime, but LRGB, it's going to be limited to not having the angle to the moon coming at you. So that was how I originally started shooting. Probably a month into shooting, I found out about this, started using it. And then I eventually moved to Astrospheric. So this is the same location. We're looking at the same night. And you really got to look at this cloud model. So the colors here are saying blue, red, and green are 3 different cloud models. When they agree, they blend just like a color wheel blends into white. So wherever it's white, the cloud models are in agreement that it's most likely going to be clouds in that area at that time. Now this updates, like I said, every 6 hours on, I think, most, if not all, the cloud models. And if you don't have any clouds, generally you don't have to worry about rain. There's nothing in here that talks about precipitation because you really need to have clouds, right? So really all you're looking for is, down here you have transparency, seeing that we talked about, and the cloud model. Now across here, there's little tiny discs here showing the 3 cloud models independently. Like, so if I click on here, there's one at the bottom. So if you were looking at where we're at, the red would be the GFS cloud model is hitting right on at that, but the others are not agreeing with that. And you can also see the percentage down here in the cloud model, 004%, 69% is coming off of another cloud model. So you can look at independent traditional cloud cover. You can look at MBM model separately, but I like to use this one, blended model. The other thing you can look at, even though it's on the chart here by color band. So if I'm looking at this midnight, this line represents midnight, and this is the blue represents time of day right now. So you can see it coming up. And you can also see the moon. Here's the moon phase. Just like on the other one, we got a nice visual how high in the sky the moon is. And then, like I said, later on, we can see how you determine angles to that, so that you obviously don't want to be shooting LRGB like here at 7, but the good news is it's going to be morning by then. So you could pretty much get away with shooting LRGB most of the night on this one. I try to just pick a night where it's completely, like down here in this future chart, where it's completely gone. If I have a good night, like here, coming up, which I can't see through Saturday yet, it only shows you the details for the first few days, as these are more speculative out here. But this would be more of a potential LRGB, because I can see the darkness coming. Seeing and transparency are looking good for now, forecasted. Nothing else on here looks any good. This could potentially be an LRGB night. Up here, I'm looking, and that if Monday, this is actually could be a shoot night early on for LRGB. This bottom seeing portion, you can see down here, transparency and seeing. The seeing's above average. Oh, in general, like if I'm clicked here, seeing average on this one, transparency below average. Out here, transparency average, seeing above average. I do not shoot unless these are both at least average. And if they're both at least average, but one of them or both of them are above average, and we'll get into multi-site planning later, but even if it's like during a work week and I'm going to have to be up, potentially up late off and on, I try to do whatever I can to shoot those nights regardless. I have 3 sites. I have my parents' farm. It's about an hour and a half from here east. I have a dark site's about an hour and a half southeast of here, and forms like a little triangle between my house, my parents' farm, and the dark site. And the dark site and my parents' site are both of Bortle, like Bortle 3.5. I'm sitting in a Bortle 5 to 6, depending on direction. I look at those 3 sites and I toggle between them, and whatever site's best, I will travel on Friday night or Saturday night to one of those, or I can go to my parents and stay overnight during a weekday if it's a really, really good night. If it's an awesome night, like these are at excellent, if I had an average and an excellent, or above average and an excellent, and it's at a dark site, I would consider going to the dark site, doing the shoot, packing up, driving home, going to work. I mean, that's how important an excellent night would be within an hour to an hour and a half drive for me. That's kind of how I plan. You know, there's locations using the weather. That's how I plan the locations using the weather. Other things to consider, you have temperature down here. So temperature, this graph shows that dew point is not going to be an issue. Let me find a different one. All right, so here's a different one. Big Bend. Notice over here we have 1. There's the excellent seeing shown here. Now it's during the daytime, so you wouldn't be shooting, of course, but as an example. Well, here's nighttime, excellent seeing, average transparency, and we're looking at, and we have at that particular hour. Now this night is not necessarily good. You got clouds popping in potentially here, though it's, you know, it's not really the best night in my opinion for shooting with this cloud cover. You'd be surprised. Some of this, you know, predicted cloud cover could turn into more serious cloud cover off and on. But there's the example of excellent. But this over here, if this were the shoot night, this dew point, it's going to telling you you're definitely going to have water developing on the lenses, the scope, etc. if you do not have dew heaters on your equipment. I had dew heaters right out of the gate. I mean, I researched everything to the hilt and jumped right into mono with a 81 millimeter refractor, fully automated, filter wheel, etc. right out of the gate. So I learned about this like before I even started shooting, and had auto dew heater system operating from the start. Even before it gets that close, like this 63 versus 66 is basically telling you when you get within a few degrees, you're going to start needing to have your heaters rolling. So with the automatic systems, it detects the humidity, dew point, etc., and it will kick in and elevate the heat as needed until it's at full power. So that's how I plan for a location. Looking ahead, I have the app on my phone for Astrospheric. I look out for multiple days, looking for a night to shoot. And if you were to look at the comparison of this Monday forecast, you know, it had some cloud cover, green. Basically it's green on this one as well. So it does show below average transparency. That's one of the things about the clear outside. If you look at the overall information listed there, it does give you an astronomical dark, nautical dark. That's something I'll cover later, maybe another video, but it does give you some of those details. It doesn't really cover the transparency portion, like over here where we have a good visual indicator of what those would be. So that's why I now use Astrospheric. All right, so that's it for this video. I hope this helps with your planning, regardless of your telescope gear or where you live. And if you got something out of this video tutorial, please like and subscribe. I hope to do more. Clear skies.